Okay, this is 4D, and this problem asks you to estimate the end-to-end chain length given this data from the earlier problem. That the weighted average molecular weight of this sample is 72,000 grams per mole. So let's see. I'm going to pull up a window to do these computations. So you kind of need to know that you recall that the polystyrene mer looks something like this. You have carbon, carbon, hydrogen, 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 and then coming off the side here, a benzene ring. So this is essentially, this represents 1, 2, 3, 4, 5, 6 carbons, and then 6 hydrogens, missing 1, so we have 5 hydrogens in this part of the molecule, and that this is the repeating unit, and we have 2 carbons here, and we have 3 hydrogens here. So that if you add all these up, it turns out that this is 102 grams per mole. And I won't do that since I know you know how to do that. And so to compute the end-to-end chain length, we know that there's 72,000 grams per molecule, per mole per molecule. And we know that there are 102 grams per mole per mer. And that this chain length right here is 0.154 nanometers. Now, so we need to make some assumptions. We're presuming these are all kind of connected in one long chain. What is the distance that we're dealing with here? So from the beginning of this chain to the beginning of the next chain, we can tell ourselves, well, in the simplest case, if this were a straight line, this would essentially represent 0.154 times 2. 154 times 2 nanometers. That would be the length that we have from mer to mer. But in reality, I don't know. I'm sort of being persnickety here, but we know that there is actually an angle. This bonds like this along the chain. It actually goes up and down, and this on the average is, I think, something like 107 degrees. So that this length right here from this mer to the next mer is not actually 1.154 times 2, but actually, let's call this angle half of 107. Let's just call it 54 degrees. And so this length right here would be the sine of 54 degrees times this 0.154 nanometers. So we know that the intermol mer distance is the sine of 54 degrees times 0.154 times 2. And from this value, if you take this ratio, the grams per mole cancels the grams per mole, and we end up getting about 105 mers per molecule. And we know that from this computation here that this is the length, this number of nanometers per mer. And so we're going to take this value, we're going to multiply it by this value. So 105 times 0.154 times the sine of 0.54, this is about 0.8 times 2, and we're going to get that, let's see, I'm going to estimate this stuff. So I'm going to call this 2 times that, I'm going to call this 0.3, I'm going to call 0.3 times 0.8 is 2.4 times 100, and 5, let's call it 100, 2.4 times 100 is 240 nanometers per molecule. So that's the approximate length per molecule, 240 nanometers.